Welcome back to your second and final lesson of the day. And this is the third and final piece of the trig unit, which is cosine law. Just like sine law was only sine, cosine law is only cos. And if you're wondering if there's a tan if there's a tan law, there is not a tan law. So all you have to know for this unit, SOHCAHTOA, sine law, cosine law. Our learning goal, pretty self-explanatory. We're just going to use the cosine law to solve for angles and side lengths. Again, this is what we use on non-right triangles. Just like sine law, there's two different versions of this, one for sides and one for angles. And again, you don't have to worry about memorizing these. They'll be given to you on your test and on your CCA for that matter. So let's start for sides. A squared equals b squared plus c squared minus 2bc cos A. So it looks kind of crazy. It's not that bad. It kind of looks like Pythagorean theorem a little bit. Really the only pattern, again, those letters are just placeholders. The triangle could be labeled with any letters. The pattern that you need to know here, though, is that this letter, don't know why I did that. This letter and this letter have to match. So small a, capital A. If I was looking for side B B squared, and then cos B. If I was looking for side C, C squared, and cos C. So all those letters are interchangeable, just whatever you're looking for, the side length has got to match the capital letter that's beside the cos. For angles, cos A equals b squared plus c squared minus a squared, all divided by 2bc. Very similar pattern. This letter right here that you're looking for has to match the letter on the back end, which is being subtracted. Everything else is interchangeable. Again, of importance here, only for non-90-degree triangles. And cosine law actually is the only formula that you can use if you weren't given any angles. So if you're given all three sides and no angles, cosine law is the only one that you can use. So only formula with no angles given. So make sure you have those formulas in front of you as we go through the examples. Our first example, again, you're copying this down on paper, so take a second, pause the video, copy down that triangle, and then come back and we'll label it and do the solution together. First thing you're looking for, is there a 90? The answer is no. So we know we're not doing SOHCAHTOA or Pythagorean theorem. So on a test, you're going to have to decide between sine law and cosine law. First thing, label all your sides. Small a across from capital A. We already have side C labeled and side B. Then you're going to go to this chart, just like we did with sine law. Fill in what you know. Side A is 26. Side B is 12. I'm looking for that. Capital A don't know, capital B don't know, capital C is 60. So remember, your look for, your visual cue for sine law. You have a complete letter. In this case, I do not have a single complete letter. Now, we encountered this problem yesterday on our last example, I believe. And we had a simple way of getting a complete letter, and that's because we had two angles and then we could do 180 minus to get the third angle. Unfortunately, I can't do that on this one because I was only given one angle, which was C, which is 60 degrees. If you can't get a complete letter and you don't have an easy way to do it, like we did yesterday, that is your visual cue to do cosine law versus sine law. So on a test, if you can get a complete letter, you know to do sine law. If you can't get a complete letter, you know to use cosine law. Now we're being asked to find side C, so we're going to use the cosine law for side lengths, and instead of starting with a squared, because we're not looking for a squared, we're looking for c squared. C squared equals, and then you just interchange the other letters. So a squared plus b squared minus 2ab times cos. And remember our pattern is, since this is small c, this has got to be capital C. And then from there, you just sub everything in. So 26 squared plus 12 squared minus 2, and then 26 and 12 cos 60 degrees. Now that looks tough, but you literally can type that into your calculator all in one step. So 26 squared plus 12 squared. Then type in minus 2, open bracket 26, close bracket, open bracket 12, close bracket. Then cos 60. Hit equals. Hopefully you got 508. Now maybe some of you are thinking 508 centimeters, whoa, that's way different. And I know yesterday I said triangles aren't to scale, but that's like a huge, huge difference. So remember, that is actually not C. We haven't been writing it, but don't forget, this is C squared. That's not C. How do you get rid of a squared? Hopefully you're thinking square root. So C equals the square root of 508, which rounded to one decimal place is 22.5 centimeters. So even though the formula looks long and complicated, it's really not that bad, and it's only 2 lines of work if we don't write down that initial formula. Just don't forget to do the square root step. So don't forget to do that final square root step. Example 2, we're going to find angle A, and we're going to round to one decimal place. First, check for, is there any 90s? No. Label your side lengths, A, B, C. Make your chart. Fill in all your information, 7, 8, 10, and that's it. And capital A is what we're looking for. There is not a complete letter. That is your visual cue to use cosine law. And in fact, if you refer back to that first formula slide, one of the star points we wrote down was this is the only formula you can use if you were given 3 sides and no angles. And we weren't given any angles, so right away, cosine law. Now I made life easy on you for this because I said just to find angle A, and that was the formula I gave you with the letters filled in. So we'll rewrite it. Cos A equals b squared plus c squared minus a squared over 2bc. And you fill that in. So a squared plus 10 squared minus 7 squared over 2 times 8 times 10. Now this, unfortunately, like you could, but it's complicated. So what we're going to do is, we're not going to enter this all in one step. We're going to do the top first. So I'm going to put a little number 1 here. Do the top first and do the bottom second. So top first, 8 squared plus 10 squared minus 7 squared is 115. And then do the bottom next, 2 bracket, 8 bracket, and then 10 in brackets is 160. And remember that's cos A. So you don't type in cos of 115 over 160. You have to remember whenever you're looking for an angle, you have to do the cos inverse. Use the shift button or second function depending on your calculator. So capital A equals cos inverse 115 over 160. And you type that in just like you see it. So shift or second function, cos, open bracket, 115 divided by 160. We want to go to 1 decimal place, which actually just rounds down to 44 degrees. So not too bad, just got to practice it. Our third and final example is a word problem. So I'll give you a second to copy it down, pause the video, draw your little triangle, then come back to the solution. So the question reads, 2 hikers set out in different directions from a marked tree on the rail trails. The angle between them is 55. After 2 hours, one is 6 kilometers on his path and the other is 9 kilometers on their path. How far apart are they? So we're going to draw a triangle. And it says the angle between them is 55. So the angle between them is 55. After 2 hours, one is 6 and one is 9. Doesn't matter for a test which one you called 6 and 9, but for our sake, let's just have the same thing. So the bottom I'm going to call 6 kilometers, and the top I'm going to have 9 kilometers. How far apart are they? So I'm going to call that x. So let's make our chart. So we have x, so that'll be angle x, and we'll just use x, y, z. So that's y, and that is z. So x, y, z, x, y, z. That's what I'm looking for. Y is 6, z is 9. Angle x, it's 55 degrees, and I don't know y or z, and I don't have an easy way to get them. Do we have a complete letter? The answer is no. That is our visual cue to use cosine law. So I'm not going to write the formula this time, it's just basically patterning. So start with what you're looking for. X squared equals, and it's the other two sides, so 6 squared plus 9 squared minus 2 times 6 times 9. And then again, this is x, so right beside cos should be angle x, which is 55 degrees. You literally can enter that all in one step. 6 squared plus 9 squared minus 2, and then bracket 6 and brackets 9, and then cos 55. It equals, we'll go to 1 decimal place, 55.1. And remember, that does not mean they're 55.1 kilometers apart. This is x squared, which means you have to square root it. Square root 55.1, 7.4. Don't forget a therefore statement. Therefore, they are 7.4 kilometers apart. One thing I want to leave you with thinking about is, what if instead of giving you their distances, I gave you their speeds? So what if I gave you this question, but I said one was traveling 6 kilometers an hour and one was traveling 9 kilometers an hour. How far apart are they after 2 hours? So there might be one additional step there. I'll leave that with you. Think about it. So again, think about how you would answer this question or how you would start it. If I said one went 6 kilometers an hour, one went 9 kilometers an hour, how far apart are they after 2 hours? You have to deal with the time and the speed, but I'll leave you with that perhaps to practice. In fact, it might even be a good idea for you just to do that as a practice question, or at least make sure know how you would answer that. There are the 2 achievement checks I would have given you. Again, they're good test practice, so try them if you really want to. Check with Mr. Hack to make sure you got the right answer, or send me a picture on D2L, Hasia, or email, and I'll get back to you. Some of you already have been sending me your achievement checks, and I've been getting back to you. Yes, this looks good, or no, let's adjust this. And your work, you are going to work on 3.4, and I believe I gave Mr. Hack a handout that's got sine law and cosine law mixed on it. So that would be something else to work on to make sure that you're where you need to be for when we come back on Monday. So that's it for this week. Have a great weekend, and on Monday we will have a couple of review lessons. You'll have your test, and then you'll be moving on to your week A classes. Talk to you Monday.